Hey guys, what's up? Eddie Alho here with KissAnalog.com. Today, I'm sitting here with Zotek, or Zoe, the new bench meter. It's a digital oscilloscope, it says, but it's also a multimeter. It's one of those kind of guys. So, Mr. Dave, I've looked at a bunch of reviews, so you guys have seen this on the market. I got this a while back ago, and maybe I could have been one of the first, or not the first to put it out there, but I got so many things stacked up, I kind of fell behind, blah, 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 all that kind of stuff. Anyway, I started watching reviews come out, and I was like, okay. And what, I like watching reviews, but really, watching a review from someone like Dave, it's just a professional review. It almost seemed like a lot of the other ones were almost tailored off of his, or at least they reviewed his before they did theirs. I don't know. I could be wrong. But anyway, this thing here has been reviewed very well. And Dave, our Aussie buddy, he actually liked it. Kind of blew me away because, usually this lower cost stuff, let's just face it. I mean, I think some of those, the name brand stuff, I think they're, he's got relationships with those guys. So he's kind of, hasn't been real positive about this kind of stuff, but he was with this one. So he's turned a leaf, or he's truly impressed. Either way, I don't think he would act impressed if he wasn't. So I guess that said, watch his review. It's a good one. He did teardown. In this review, I'm going to kind of show you some stuff, and I'm going to skip the teardown. Sorry about that. If you wanted to see a teardown, I'll do it. But Dave did such a good job. It's like, but in this one, I got this flyback regulator over here, this power supply. So I thought, let's look at some real signals. Let's talk about some real things you can do with this meter. So let's just jump in this video and let's try not to make it too long, okay? All right, thanks guys. All right guys, I plugged it in and I was expecting a display to turn on because I want to charge it up before I start showing you guys how it works. Just make sure I have a good battery, because you can't ship lithium batteries. I think you're supposed to ship them, I forget what it is, 50% charge or something like that. But check it out. You can see that light glowing. So I can see it here with my lights on, even in the bench. But I was just looking up here. Once I looked down, I went, oh, the light's glowing. So yeah, you do get an indication that you're charging. So just wanted to point that out. Okay, so just to show you the rest of the thing, just to turn it on, just to see what the display shows when it's charging. Can you see that? You can see the little lightning thing on the battery. So it does show. And look at that nice display. And even with my lights make it hard to see anything in here. But even with my lights on, you can see how the angles that display, hopefully you can, that it looks really nice. And then you just hit this mode button. And look at that. Man, that is one nice display. So, and see the function buttons across here. I imagine I push this. Yep, you get that. I mean, it's pretty, like Dave said, it's really intuitive. Alright guys, I've charged this thing up. Now it's time to turn on the display. Now, the thing about this display, whoops, I guess you gotta hold the button down for a moment. The thing about this display, it's what they call an IPS display. And so I'm going to turn it on scope meter mode. But this, hopefully you can see this in my lights in here. But I'm turning it at different angles so you can see it. This IPS display, of the different types of LCD displays, it has the best contrast, the best color. Now, the reason why gaming, a lot of things don't use it because they're used for gaming and stuff like that, is it's actually slow in response. But for multimeter, you're not looking for super fast response. You're not watching something fly across the screen. So, like a football game or something like that, right? Where you're watching a baseball pitch and the ball would look kind of funny if it didn't travel fast enough. So this kind of screen is awesome for multimeters. It's also, of the different types, it's the most expensive. So Zoe didn't spend it, you know, I mean, they just chose it based on what's the best for a multimeter. They didn't, you know, they didn't worry about the cost of the display. So that display, from costing them more than one of those ugly displays you've seen for 20 years on other multimeters. So anyway, just putting that out there. So you can see how nice the display is. I guess I should just show you the close-up of it. Hopefully that's in, I'm turning a different angle so you can see how good it looks. But man, I hope it comes out in camera as good as it looks in person. But that is an awesome display. And then we go to scope mode. It's just neat how easy it is to go between them and how intuitive, how everything's, you know, I mean, you just look at the display, look, there's a max, min, and average. I mean, wow. 10,000 counts, plus you get max, min, and average just as a default for readings. That's amazing. That's awesome. And you got a hold, auto range, so we can manually range if we want to. I mean, hold it down, goes back to auto. So very nice. And we're going to have to look. So one of the things that people have caught other reviewers is if you're in the milliamp range and you go above the range of that milliamp, which say is 200 milliamp max fuse. So if you go above that, then it has issues. It gives you a false reading. So I guess what that means is you have to be aware of what you're reading and know when to switch to 10 amps for milliamps. But yeah, so there's some things that might be fixed in firmware down the road. But man, for what most of us use these multimeters for is reading volts and all this other stuff over here. It's 10,000 counts. It's awesome. And then it has a scope on top of that. So anyway, we're going to take a look at this and let's go ahead and take some measurements and see what it does. By the way, there's a temperature thing up there. So when you click on that, we're on Celsius, and then down here says F, Fahrenheit. It'd be cool if you could toggle between the two, but I guess it sounds like you can't. No one's knows or found out how to do that. So anyway, so that was the temperature thing. Alright guys, so this is the box. Scope on that side, multimeter on that side. You got your scope probe. It's just like, it's very similar to the one you get with the Signet scope or Mixig or anything else. Perfectly good scope probes, by the way. And these test leads, look at this. When I unfold them, look how soft they are. They just unfold. I mean, they're not silicone, but God, they almost feel like it. They're very soft. Long tips, gold tips, and sharp. They look like gold, yeah? Yeah, they're gold plated. So, man, very nice tips. And those are just protectors because these things are so sharp. But anyway, I guess you could clip off the top if you wanted to have a little probe, but they are kind of loose. So, yeah, you know, these kind of probes are somewhat common. They have nice tension relief here, and on this end they're kind of angled, so that's kind of helpful sometimes when you stand up a meter and you want them to angle away instead of hitting the bench. So if your probe wants to exit like this, if you know what I mean, having them angled like that helps that. I think that's why they do that. But they got the grippy things here. So anyway, the leads are nice. And guys, there's a bag that comes with it. And by the way, this little manual that Zoe or Zotek puts out, they're always, you know, really nice. They're pretty simple. I mean, it's a multimeter, right? But like in this one, they have color pictures. So yeah, they've done a nice job. And it's actually like 27 29 pages. No, it's more than that even. Anyway, and this is all in one language. This particular one's in English. So yeah, you got like 29 pages of English. So so nice little manual. It fits in the bag. I really like that they give you a bag. They got the USB to USB-C for the charging, so that's nice. Then we have our basic scope probe accessory package. The compensation screwdriver that's plastic that you want, and the little plastic tip protector so that if you're going to probe a circuit but you don't want to accidentally short something, and then all the different color bands, even though there's only one scope probe, so that's kind of funny. But yeah, so that just, you know, I'm sure it's a scope probe that would normally come with the, well, it says 60 megahertz, so yeah, it'd come with the normal oscilloscope. So they just got one from someone, and what was nice is it's also times 10, so that's really nice. But yeah, this is your thermal probe. This is the kind that's meant more for like fluid and that kind of thing. But yeah, the other ones are so much, you know, you usually get the other type with every kind of meter, so it's kind of nice to get one of these with the meter, so you have one of these guys, and it does come with the bananas, so you don't need the adapter, so that makes it nice. And then the meter, so we're going to take this guy off. Sometimes I leave them on there because I plan on giving the meter away, but I might keep this one for a while just because it's so nice. It's a nice display. I might want to show it in a couple videos, but eventually I'll probably give it away. It says stop testing voltage and current mode. That's pretty funny. It's pretty, I mean, it's, you know why they're doing that? Because so many people, like myself, when you're first learning, so many people will measure voltage and measure current, especially when you're in a lab. You're learning electronics. You're always measuring current. You put your meter, your probe there. The next lesson says, okay, measure this voltage. So you turn your power supply on, you go probe it, and it's still in the current mode, and you blow the fuse. So, but it is a 10 amp fuse. It says fused, and also it says 200 milliamp is fused. So there's two fuses in it. Which is super nice. Of course, we know it's rechargeable, right? USB rechargeable. And so there's the port there, and there's the compensation connections for your oscilloscope, your ground, and your return ground, whatever you want to call it, and your plus tip. So we will compensate that probe. Here's your probe, and it's kind of recessed down in there, I think, to protect the BNC, of course. So now that says Cat 2, which is typical for an oscilloscope. Okay, so the nice thing about this is floating. So it's like using a differential probe. You put a probe in there, that little ground's not connected to anything except for the battery in this, so you can put it pretty much anywhere in your circuit and use it like a differential probe. So that's a really cool feature of this. Now, people have talked about this thing that they're not super excited about. I think it's just because it doesn't click into place. But other than that, it's a kind of hard plastic with some kind of flex to it. So it seems to me like it's going to hold up better on the bench than some of the other more expensive meters you might know about that have really crappy things. So yeah, that's not as bad as I think people have made it out to be, but it's just that it's kind of floppy. Now the thing is the case, it's got this soft rubberized, the red's all soft rubberized, and the black is plastic, hard plastic. So it's all integrated, so you don't have a boot you have to peel off or worry about not sucking in. You know, some of them suck in really well, some don't. This one's all integrated. Now the thing is the hard plastic's right here, so if you did drop it dead center, then that would not have any protection there. It's going to hit hard plastic. But this plastic, this meter feels super tough, and so I think it'd, you know, survive a land fine. Now it has these red dimples here and the square one's up here. So if you do set it on the bench, it's going to grip. So anyway, construction seems really nice. And of course, there's your manual for your scope probe. Alright guys, this is the first time I plugged leads into this, so I haven't really played with it. I should kind of learn how to use it before I try to show it to you guys, right? But at the same time, what I want to do is, because it's got a completely different type of menu, I just want to see how intuitive it is. Whoops. These leads, you can tell they go in there pretty tight. Okay. So, you know what? Let's see how fast it is to go to continuity. Now, I know that that's the multimeter mode. Okay. And then up here it says ohms, and it's got the buzzer there. So, there we go. Now I see it starts off in ohms. Oh, wait, hold on. Was that continuity? Oh, yeah. And then there's a little buzzer, so I think this is continuity. Wow, that's pretty darn fast. You can see it's latching. I don't know if you can hear that, but it sounds pretty darn good too. I should pull out my sound meter, huh? That's what I meant to do with that thing. Alright, so let's see. You got hold and save, auto range. We got the amps. Now, okay. Well, there's a real quick message. Did you guys see that? Let's do that. Let's see, what's the menu button do? Okay, backlight, 100%. You guys see this? Let me show you. So when you hold that down, it says English and auto off, cancel. So that's cool. That's really quick to get to. You know, it's kind of a bummer, like sometimes when you have to memorize like which button to push when you power on, right? It's kind of nice to be able to power on and say, oh, look, let's just turn off. Oh, look, 15, 30, 60, 120. Or cancel. So that's pretty cool. I like that. Backlight. Okay. Software version. Yeah, I wonder if there's going to be a, you know, I guess I should check for a software version update. And then we're back to scope. And if I go to menu on this guy. Alright, we got AC coupling. So DC coupling, AC, trigger modes, auto, normal, single, okay, trigger rising or falling, so okay, and probe compensation 1 times or 10 times. Wow, so okay, so you don't have option to go into like say 100x or something. So if you had a high voltage probe, that's kind of too bad, huh? Because I could see people wanting to use this for automotive reasons, and a high voltage probe would probably be good for that. You have the left and right buttons. Okay, calibrate off. And by the way, you'd want to turn this on, let it run for a little bit before you do the calibrate, I think, to let the temperatures kind of settle in. Even this thing's probably not going to get very hot, so you probably don't need to leave it on very long. But reset off, storage enter. So disk driver, press F2 to exit. Huh, that's pretty cool. Okay, volt time, move, trigger, AC. Okay, trigger, move, volt times. So if I want to change my volt times right now, let's see, voltage peak to peak. It's taking some measurements automatically. Up here it says 1 volt per division, I guess. So if I go to, yeah, so I'm at volts right now. So I suppose, okay, there's 2 volts, 2.5, 5. Okay, so how low can we go? Okay, 20 millivolts per division. And times over here, 25 microseconds. How low can we go? Wow. Okay, 100 nanoseconds. 10 megahertz scope, that's appropriate, I guess. And let's see, AC. Okay, AC or DC coupling, I suppose is what that is. So yeah, okay. So it looks pretty easy to get around. Let me hit menu again. I'm gonna go to probe and do it this way. See if, no, okay, I was just wondering. 10,000 count true RMS with the scope probe. Let's take some measurements and see how this guy works out, okay? All right, guys, let's check the voltage for the diode. I got that diode mode, so let's check that out. If I can do this. 3.2 volts almost, so that's good. That'll cover most diodes. Great. All right, so in diode mode, let's see if it beeps when it's shorted, and it does not. That's too bad. And we'll put, oh, you know what? These big transistors are kind of fun. Now this is collector, the case, and the base, and the emitter. So we'll put the red on the base to see if it's an NPN. And we're in diode mode, so should we, whoops, so we should read diode drops. 0.5 we do. And 0.5, great. Then if I reverse it, put the black one on the base, I should see opens. Okay, cool. Cool. Yeah, big transistor. Alright guys, I got the probes hooked up to my power supply right here. I'm going to go ahead and turn it on and just show you how fast the digits change. Look at that, 3 decimal points at 9 volts. That's awesome. That's the 10,000 counts. And I'll just wiggle it around and show you how fast it moves. I mean, I think the display is very quick. Okay guys, what I want to do is show you the hold function, or relative function. Sorry, let's do the relative. So it'll zero this out. So let's say I was reading an audio signal and I was reading AC, right? And I'm doing 1 kilohertz and I want to see what the output is. But then I want to go at different frequencies and see how flat it is. See what the frequency response is, right? And then I can plot out my Borbede plot by hand. So what I could do is I go relative, okay, 0. And then I could change the frequency, change frequency, and each frequency I could see what the change of voltage is to see how flat it is. And so relative mode's really nice for that. It's also, if I'm charging something up right now, let's say I'm charging this, and okay, there we go, it's charging. And then I can go, okay, I charge 0.8 volts, good. So there's lots of interesting things you can do with relative, and just wanted to show you that. It's really nice, and we'll just take it off. Go back to the voltage reading. All right, so let's see what happens when we go over the 10,000 counts. Oh, and we lose that decimal spot. So right at 10 volts. Okay guys, one thing I wanted to point out is you have a max, min, and average in DC readings. If I was in AC, I'd have max, min, and hertz. So it's kind of cool that you get all those things displayed at one time. And we go back to DC. Hey guys, so I do have these pretty high tolerance resistors, but you know, I've had them for a while and stuff. But this one's a 100K resistor with 0.025%. So, yeah, I don't know. I don't know how calibrated they are. But if you want to just look at some measurements, this is 10K. One thing, you can see how fast it goes from 0 to the reading. Pretty fast, right? Again, 0.025, 10K. So that's pretty darn close to that number. But yeah, it just gives you an idea of how fast it dials into the reading. This one's 100 ohm. Okay, same kind of tolerance, 0.025. And okay, we got another one. What do we got? We got 10 ohm. Yeah, that's a 0.05%, so that's looking pretty darn good. So I don't know how accurate those are. Now this is, here, let me plug the leads in. All right, let's try this resistor. Okay, yeah, it's supposed to be like 6 meg, and it is pretty darn close. It's a Simpson resistor. Again, been around forever. Okay, guys, this is actually pretty impressive how high it'll go. It's supposed to go up to 100 millifarads, 100,000 microfarads. I've got this 10,000 microfarad here. So let's see how long it takes to read this. Well, should we go to capacitance first? Let's try that. All right, yeah. Often I've found, and this cap usually reads around 9 millifarads, and it takes, it takes a little bit to come up with reading. I've noticed in other meters it takes a few seconds like that. Whoops, let me get the finger off one of those leads. 370 mic. And it's supposed to be 330, but yeah, these aluminum electrolytics aren't real high tolerance caps. Alright guys, okay, let's read this little one. This little one is supposed to be 68 nanofarads. It's an XY cap, poly. And it is 68 nanofarads, so yeah. Alright, so this button's kind of fun. It does millivolts. Look, it reads temperature, ambient temperature. Down here, F 73, min is 0, max is 23. So I can hold that, and it's going to creep up a little bit. You know what? Let me hit the relative, zero it out. See how much I can change it just holding it. Changed a little bit, not a lot. Okay, so min, max, 4 degrees, max change, min 0, temp 37F. So take it off relative. And we're 30C, minimum's 29C, and temp is 84. So we got the max 30. Okay, let's try the oscilloscope function, okay? Now, one thing I want to mention is these probes, they're recessed, right? And really, the bayonet, it's a bayonet type mount, and they have these little lugs on the side. So when you drop this in and turn it just a quarter of a turn, not even maybe a quarter of a turn, that's all you need, and it locks it right in, okay? So you don't need to crank on that thing, and it's going to stay there, okay? But anyways, there we go. We're in scope function now. So let's try to look at some signals. Alright guys, so I've got this connected. The tip on that thing, the ground on the little ground lug. Unfortunately, they show the earth ground symbol. That's too bad. They should show a little triangle, but yeah, we got to stop doing that, guys. Anyway, just perpetuate something dumb. So, alright. I'm going to hit the auto range, just see what happens. First time I've tried to use this scope, auto setting, takes a bit to do that. And then, okay, so captured the signal, but we want to compensate the probe, right? So what we want to do is, okay, we're in volt time, so I think volts, yep. So I can do this, right? And then I can move it. I can move it on down. I want to amplify the signal, so I've got a good edge on this thing. I have a video where I kind of show how to do this. I'll put the link down below. Okay, so now I want to go time 1, spread it out. Is that doing it? Oh, I'm still in move. Sorry, got to go back here. Okay, I got to go this way. Okay, now I need to go to move. And it's actually fairly flat on top right now. But let me get that little screwdriver and we'll see if we can flatten it off anymore. I had to rotate this so I could get to it. And, like I said, it's pretty flat. So what you're doing is there's an RC filter, well, it's in here. And there's one inside the meter, and you're just aligning them. Okay, that looks pretty darn good. So I'm going to hit the auto range again. Auto range is not fast. But yeah, that looks good. Alright guys, we got a flyback converter here, right? It's a power supply. Let's say that we're not getting any voltage. We got a problem. Oh, I haven't hooked it up. No, let's say there's a problem there. Okay, so I got it in continuity mode. So what I might do is, first of all, I see a fuse. Now I can actually see the element, so we know it's okay. But let's say it was a ceramic and I couldn't. So I'll check the fuse. Yep, and it's good. So I can go from the line. Yep, yep. And then I can go up to see if it goes all the way up through here. Make sure one of my chokes didn't open. And I can go to the diode, the bridge rectifier. So it goes outside the bridge right there. So now I can come back and go to my neutral and go to the other side of the bridge. Yep, the other side's right there. So looks like power is making it to my diodes. Let's see if it goes through my diodes. So what I can do is go to diode mode right there. And I can put the positive on the anode, which is see the line right here? There's lines here. So I go to the opposite side and do I get a diode drop? Yep, 0.55. I get one over here. Yep. Okay, then check this guy. Yep. Yep. The other thing I could do is I could come over here with my plus on my line. And I could come all the way up to the top of the diodes. These two cathodes are going to feed the positive of this capacitor. And look at that, diode drop. Diode drop. So, and I could go to neutral, and I could see the same thing, diode drop, diode drop. So, good. So my power is getting up here to my cap. Then I could go start checking transistors to see, because the most likely thing to fail, fuse obviously, diodes. I mean, diode or something might fail first, and then it'd take out the fuse. But you know, a lot of times the most obvious thing is this, the switching transistor. Okay. So if that shorts, the fuse goes. But it could take out a diode. So you just check. I know I'm good all the way to my capacitor. And then another thing you can do is you come right over to your output and check to see if you have any ohms. To see if you have a short. Now I have a load tied right there. So, you know, you'd not want to have your load connected. But you could connect that up and go, okay, wait. And that's my load right there, 5 ohms. So if I had a short on my synchronous or my diode feeding the output, then it would be shorted to the transformer secondary winding, and I wouldn't get that. So it looks like I'm probably nothing shorted here. So far, I'm not seeing it short here. Now I can go to the plus and the minus up here, and I can see if I see a short across the capacitor. Or I mean, yeah, and I'm going to see a capacitor. And I wonder if I can measure that in circuit. Let's just try it for fun. Wow, look at that. 900 microfarads. And that is a 1,000 microfarad cap. So that worked. So we don't have a short over here because we wouldn't have read the capacitance. It would have been short. So far things look good. I would go and check my FETs to make sure they're not shorted. Put them in diode mode, check those. Drain the source. And then after that, I'd look at the VCC pin to ground. And then the gate drive to ground. Make sure the chip's not dead. So that would be a quick way to test a power supply. Hey, there you go. You got a freebie in a multimeter review. Alright guys, I have this back in scope mode. We're going to power this up and we're going to look at the, I've got the scope right across the outputs. This should be 12 volt output. Let's take a look and then we'll look at the ripple as well. Alright guys, got my blast shield on, got my safety glasses on, and I'm going to bring up the voltage slow. So let's see what happens. Make sure everything's working. And the scope is set for 5 volts per division, and it looks like it's working. Alright, cool. Alright. Now you know what? What I want to do is I want to look at the ripple. So I want to put on this on AC, and we're going to go to lower volts. Whoops. We're going to go to volts, and we're going to go 1/2 volt per division. And what's my time base? 500 microseconds. We're going to go smaller than that because this thing's switching faster. Usually I go down to about 5 microseconds maybe, because that's going to capture a lot of different frequencies. Then I can zoom in. Okay, so let's go ahead and turn it on again. I'm bringing it back up slow. Okay, now that's interesting that it's got this DC offset. Here, I'm going to go ahead. Oh, there it goes. You know, I heard that this had a large capacitive filter, so it's got a pretty good sized capacitor on the input. So here, let's go down to 400 millivolts, 200 millivolts. That looks like switching frequency, right? Spread it out a little bit. Okay, 200 millivolts is the best we can get. Okay, I'm going to go ahead and hold that. Okay, I'm going to turn on the power supply so I don't have to worry about anything while we look at this screen. Alright, so check it out. It says 282 kilohertz, which that sounds about right. VPP, voltage peak to peak is 0.4, Vmax is 0.28, and that is 200 millivolts per division. So, yeah, I see some peaks up to about 0.4. Pretty interesting. We can see ripple. Alright, cool. Alright guys, so what I want to do is I want to capture the output coming up, see how long it takes to come up. So what I did is I went to volts time, and I changed that to 2 volts, just went up to there. But I also moved the arrow right there. See me move it around? There's the bottom of the screen. I moved it just off the, so it's on the first grid above the bottom. So it'd be 2, 4, 6, 8, 10, 12. So we should hit the grid just above. And if it overshoots, we should be able to capture a 2 volt overshoot even. So, okay, so after that, I went to trigger, pushed the menu button, and coupling, I think DC is okay. And I toggled to single. We want to go to single. We want to trigger 1 time stop. And rising edge is good, times 10x. Oh, we got other stuff. Okay, no, that's nothing to do with what we're doing. Okay, so turn that off. And it is back on DC. We want it on DC. So we're going to capture that. Oh, we want to trigger over here on the edge so we can see it rise up. So let's go back to trigger, hit the menu. Oh, I don't think we do that. I think we want to move. And then oh, there we go. I see it. See right up here, there's a little arrow. I'm going to move that all the way over to this. I'm going to start off the second grid. Sometimes if you trigger, and also I'm moving the trigger point. See that line right there? Whoop. Okay, move that there. Trigger. See the green arrow? Move this down. It's 1 grid above the line, so 2 volts it'll trigger. If some weird stuff happens before that 2 volt, we'll see that, and then it'll rise up. So, okay, how many volts, or time, 2.5 microseconds. We might need more time than that. So, okay, let's go volt times. And, you know, let's say it takes 100 milliseconds or so to come up. So, oh, okay, we can go to 10 milliseconds. All right, fine. And the trigger went back to, here, let me move it back over. Okay, I had to go to move. Okay, right there. Okay, so we're going to trigger right here on that first grid, 10 milliseconds per division, and right there. So we're all set. So I just need to hit the power on and see if we capture it. Alright guys, I got the voltage set. Just have to hit the switch on the power supply. Let's do it. Okay, it says wait. Okay, so it should be ready to go. Let's see if it's going to capture it. Here we go. There we go. We got it. Look at that. Alright guys, we'll check out the power supply in a moment. I just want to check this signal. And I want to move it down so we can look at it. Whoa, that moved fast. Let's go to volts time. Hey, there it is. It came back. You know, I noticed with some scopes, like even expensive scope, when you save the waveform, if you change the horizontal back and forth, it's saving a bunch of images, but it saves the one image, but it's still looking at a bunch of other images. And so sometimes you have to toggle the time base just to get the image to come back. But usually it puts them on top of each other. Okay, there we go. Look at that. It can spread it out. Look at that. So that is 2 milliseconds per division. So it's about 4 milliseconds. That sounds reasonable. It overshoots by about 1 volt. That's probably okay. And yeah, there we go. Pretty cool, huh? Now, I don't know why it shut off. That's a problem. I don't know. I don't know if that was me hitting the switch fast or if it's power supply. So let's check the power supply. So let's go ahead and put this back into, let's go ahead and see if we can capture another signal. So we'll go into hold save. So now it's waiting to capture a signal again. It's all armed, what we call it. It's armed, ready to go. Okay, so I'm just making sure everything's good. Looks all good. I'm going to go ahead and hit the power switch. Yeah, there we go. Oh, you know what? Did it come out of, no, it stopped. Where's my trigger? Yeah, it triggered off the screen, so that's a bummer. Let me move it. That time it lets me move it. See the arrow? I'm going to move it over right about there and we'll try again. Okay, so take it off, hold save. Let's do it again. There we go. Sweet. Yeah, it was me turning off the switch too fast last time because that time I left it on, stayed up. But yeah, there's our rise time. 2 milliseconds per division, 2.4. Pretty nice little scope. Pretty capable, right? Oh, you want to see something else? Alright guys, there's a flyback. I'm down here on, there's a little place to put primary ground and then the drain of the FET. So that drain's going to go pretty high voltage. Let's see if the scope can do it. Alright guys, so what I'm doing is I went to trigger, hit the menu, and we're going to take it off single. We're going to go into auto and coupling. We're going to stay on DC. Let's see what are our options. DC and AC. Okay, we'll leave it there. And trigger rising, probe 10x, that's fine. Okay, volt times. Now volts, we need to go a lot more volts. 5, 10, 20, 25. Okay, 50, 50, 1, 2, 3. Okay, we're going to see some high voltage over there because we're on the drain of a flyback. So that's going to be high voltage. So 50, 100, 150, 250, 300. That might be enough. Okay, we'll start off there. Well, actually, we'll go higher and then we'll bring it down if we have to. And we're going to go a faster time because it's going to be switching at a couple hundred kilohertz, right? So we're going to go down to, I guess, 10 microseconds faster than we go. So that'll be all right. So we're going to go ahead and do that. And take it off, hold save. And it's going to trigger right there, but that's okay. It's going to be continuous. So, all right, guys, this will be fun. Should I put the blast shield over the board? Oh, you think I should put it over the meter. All right, I'm going to stand back and I'll just hit it and hopefully I won't take out my camera, right? Okay, here goes. It's on. What are we seeing? We're capturing something? That's pretty awesome. I'm going to hold it. Now, you know what? Let's go to 50 volts because we don't need 100 volts, right? And I'm going to go to move and move it up just a little bit. You know, it did do a great job. It automatically captured the frequency, 282 kilohertz. And voltage peak to peak is 300.63 volts. Voltage max is 293. So it looks like it went negative a little bit. Okay, now let's go ahead and we're going to capture that again at 50 volts per. And let's see, do I need to move that down on that grid? Yeah, there we go. Alrighty, let's do it. There we go. Freeze it. Alright. Pretty darn nice. Now it's too bad at 10 microseconds is, you know, the shortest waveform it can capture. But, yeah. Oh, hey, how'd I go to 5? What the heck? Did I just not push hard enough before? Look at that. There we go. Geez, we can see the rising edge. We can go 100 nanoseconds. So about 100 nanoseconds rising edge. That, for that voltage, that sounds about right. And you know what? It captured, when it turned off, added a little bit of a negative spike. That's, you know what? This is doing a good job, I think. Now, this is an active clamp flyback, so that's why the waveform looks so good. But guys, there you go. Peak to peak, 485 volts it said. Max is 241. So, I'm not sure why it did that. It could be the AC coupling that was actually taking a bad reading in the beginning. I don't know. I'm not sure what that's all about. So, yeah, I don't know about that, but other than that, 241 sounds right. 50 volts per, or 50, 100, 152, 250, and there's a 300 volt line right there, and it's, yeah, that's looking awesome. And again, 282 kilohertz. Alright guys, so just a serious note, cat ratings, this thing says cat 3, cat 4, that's really hogwash. I wish they wouldn't even do that, especially on an oscilloscope / multimeter. But, you know, cat 3, cat 4 really needs to be safety certified. I wouldn't mind so much if they just said cat 3. But cat 4, no one's going to use this in the cat 4 environment. And it just makes it feel like they're not telling, you know, they're not being honest, right? Because internally they would have had to test it to that standard. And, yeah, I just don't see it happening. They've opened up this meter. I don't think I'm going to in this video unless you guys want me to, but yeah, anyway, I mean, in the next video I can if you guys want me to do a teardown of this, but Dave's done it before, so, and he did a nice job on it, and he was impressed with what he saw inside. So, but anyways, yeah, this looks good. But as far as high voltage goes, this is high voltage. Well, but it's not high energy, so it's cat 2. This stuff is cat 2. It's not even cat 3. It's not cat 4. This is cat 2. This is 120 volts coming in there. That's more dangerous than what's going there probably. I don't know. But there's a fuse there. There's a fuse back there on my little vote box I'm supplying this with. That all goes to a plug strip which has a breaker. That all goes to the wall that has a breaker. All that limits the energy in here. Everything in my lab's cat 2. Okay, so yeah, so as far as when people are knocking, you know, quotation marks, cheap Chinese multimeters, don't use them around high voltage. That's not, it's high energy, guys. Don't use them around high energy. High voltage, this is considered anything really over 60 volts DC or, you know, 30-something volts AC is dangerous voltage. You know, it can hurt you. So any of that voltage is bad for us humans, but for the multimeters, they're fine with all this stuff around here, as long as, and if they did have a problem, the surges, lightning, transients, that's the stuff that cat 3, cat 4 is dangerous. Okay, cat 3 is on the other side of my breaker panel, cat 4 is outside the house. So anyways, just want to say that this is a power supply that can be dangerous. High voltage, you know, all this, you can see it right here. You don't see me touching this stuff, and I turn things off, I connect things up. That's why I have jewelry, because my hands are nowhere near this stuff. Normally, if I don't have a camera on it, I have a blast shield, I call it. And I have safety glasses. So, yeah, I'm not an idiot. I didn't get this old, you know, being stupid. So, yeah, I just want to tell you that as far as multimeters go, they're not scared of this, okay? As far as us humans go, anything above 60 volts DC, 30-something volts AC, the voltage is lower than that. They call it SELV, S-E-L-V, Safe Electrical Low Voltage. voltages above that are not safe. So none of this is safe, okay? By the way, you see what Texas Instruments put on their board? That right there, they're serious about that, okay? But not to say you can't use any of my multimeters on the bench, or this nice little scope handheld multimeter, scope meter thingy majiggy. I think this would be great for the bench work, and I think it'd be great for doing audio work, because you can, oh, there's another thing I wanted to mention, the relative thing. What if you're trying to match resistors for an audio amplifier that I might be doing soon? You can put, say you're trying to match whatever ohms, say it's a 100K resistor, 10K resistor, you dial up a 10K, get a resistor that's close to 10K, you hit the relative, maybe you use a variable resistor, get perfectly 10K on the meter, hit relative, zeroed out, right? And then every resistor you measure that would be the difference from 10K, plus or minus. So that'd be a nice way to get your, to match resistors. Alright, so the things I love about this meter, I like the size of it, I love that crisp display, and from the electronics inside, from Dave's review, they use some really good A/D converters. They've done a good job, like an excellent job. I mean, for the price of this thing, a fantastic job, an amazing job. It's just crazy what you can get today. If I didn't have anything on my bench and I was starting the bench, I might get this Swamp Tech power supply, which I really like, and I might get this Zoe. These Kaiweets power supplies are pretty awesome too. So there's a lot of good low-cost power supplies, and actually the Matrix a little bit more expensive, but very nice power supply. So you really need a power supply, and maybe just one of these, and you're off and running. Now, also this Unity generator, or that guy up there, goes by different names. But I mean, you can start a bench for a very low cost. This is a 10 megahertz thing. You know what I really meant to do? I meant to check the rising edge on a fast edge to see what the bandwidth really was. But yeah, maybe I should do a bandwidth on this. But you guys saw me do these measurements here, and now look, we're measuring a high voltage, and that rise time was about 100 nanoseconds, I think is what we looked at, which sounds about right. And so, wow, I think for audio purposes, this would be fantastic. If you're doing that Wolverine amplifier build, and you need something to match resistors and things like that, this guy goes up to 100, like 99.9 millifarad capacitors. Like, I mean, the capacitance range on this is crazy. Now, I didn't test that current reading. I didn't even get to the current. So, man, after being in here for a couple of days, I realized, man, I had to come in here, cut down the video a little bit. And I think I even left that off. And the video, I'm sure, is still going to be fairly long. So let me know if you guys want me to do some more measurements. I am curious about the performance and stuff on the current. But what do you think? Did you like the review? Did you like the meter? I mean, for the price, I'm going to put the most current price here. The price was kind of changing and stuff, and the availability. That was one reason I held off in the beginning, is because I thought, God, what if I review this and no one can get it, you know? But you can get them now. So hey, using the links doesn't cost you anything extra, and really does help the channel. I mean, it's a small percentage, but if enough of you guys do it, it'll make a difference. It helped me buy stuff. Anyway, I wanted to do this review and get it out of the way, because I think everybody else has done it now, and I just wanted to show some real measurements. I thought that was the one thing that was missing, and I think, like I said, that display's crisp, amazing, 10,000 count multimeter, and for the price, I mean, for what, is it under $70 now? I hate to say it, because it depends, price and demand, right? But it is priced under 100 for sure, and under 100 bucks for something like this is crazy good. So yeah, I highly recommend this. I mean, I think it's a great meter, backup meter. You know, like I showed you here, well, I didn't really show what you could do with it, but you're not grounded to anything with this. So essentially it's a differential probe coming off. Those two, the negative clip and the little, you know, the two clips on the oscilloscope probe, they're essentially a differential probe at this point, right? Because they're not, you only have one input, so you can't mess things up. And the input here is isolated from this. So looks, yeah, I did an ohmed it out. Should have done that on camera again. I think I ended up taking that out. There's so much stuff you can do with this meter. I had to cut off a lot of footage, and I think some of the stuff maybe I should have kept. I don't know. But anyway, video's still long. What do you guys think? Let me know. Free way to support channels. Thumbs up. Appreciate that. 2 thumbs up. My patrons, as always. Appreciate you guys. And hopefully there's a list right here, my patrons. So really appreciate you guys. It helps a lot. And I'm getting close to 25,000. I was hoping to be there by now, but summer months, things slow down. So hopefully that'll hit, because nice to see YouTube, you know, give me a raise. I don't know if that happens at 25K, if you get more, you know, but yeah, anyway, so hopefully things go, you know, start getting better here. So you patrons, you helped me a lot. I got some stuff that I want to do for these projects, and I got to get back to them. I got a couple reviews to get out of the way. So yeah, this was one. All right, guys, and this stand might not be the best implementation. It doesn't click in place, but you know what? Once you sit on the bench, it's fine. The one thing about a lot of these really nice displays, the plastic the plastic they use, it's pretty soft plastic. So I think, yeah, it looks like I cleaned it off. I thought it scratched, but it looks like, yeah. So anyway, I'd be careful with them because they might scratch easy. So yeah, that's the one thing about them. But you know what? They're so inexpensive. They get all scratched up in a year or two, just go buy another one, right? And then you have 2 of these bad boys. But all right, thanks for watching. Better cut the video short before I make it longer. We'll see you next time, guys.